How many types of stars do you know? The universe is teeming with stars, each unique and fascinating. Like cosmic fingerprints, no two stars are exactly alike. Their size, temperature, color, and lifespan vary greatly, a testament to the immense diversity of our universe. In our journey through the cosmos, we'll explore 10 different types of stars: main sequence stars, giant stars, supergiant stars, white dwarf stars, brown dwarf stars, red dwarf stars, blue giant stars, variable stars, binary stars, and lastly, neutron stars and pulsars. Understanding these heavenly bodies isn't just about stargazing. It's about appreciating the fundamental forces that shape our universe and our place within it. The more we learn about these celestial wonders, the more we unravel the mysteries of our own existence. So let's dive into our cosmic journey and start with the most common type of star, the main sequence stars. Main sequence stars, like our Sun, make up about 90% of the stars in the universe. They're the workhorses of the cosmos, burning bright and steady for billions of years. In terms of size, main sequence stars can range from 1/10 to about 20 times the mass of our Sun. Their color, from cool red to hot blue, depends on their surface temperature, which in turn is influenced by their mass. These stars play a pivotal role in the universe as they are the principal source of light and heat. They also forge elements heavier than helium in their cores through nuclear fusion, spreading these elements throughout the universe when they die, contributing to the birth of new stars and even planets. So in a way, we're all made of stardust. From the most common, we now move to the grand and spectacular, the giant stars. Giant and supergiant stars, as their names suggest, are some of the biggest stars in the universe. These celestial giants are several times larger than our own Sun and shine with a brilliance that can outshine thousands, even millions of suns combined. Their color often varies from yellow to red, with the red ones being the coolest and the yellow ones the hottest. In terms of lifespan, these stars live fast and die young. They spend their lives fusing lighter elements into heavier ones in their cores, creating elements as heavy as iron. But the grand finale of these stellar behemoths is truly spectacular. When they've exhausted their nuclear fuel, they explode as supernovae, scattering their enriched guts across the cosmos. This supernova explosion is so bright that it can briefly outshine an entire galaxy. It's from these stellar explosions that elements heavier than iron are formed. From these titans, we move to the opposite end of the spectrum, the white dwarf stars. White and brown dwarf stars are the remnants of once active stars, now quietly fading away. Let's delve deeper into their intriguing characteristics. White dwarfs, despite their small size, are incredibly dense, packing a mass comparable to our Sun in a volume similar to Earth. They're essentially the leftover cores of stars that were once like our Sun, but have exhausted their nuclear fuel. On the other hand, brown dwarfs are a bit of a cosmic oddity. They're failed stars, with not enough mass to kickstart nuclear fusion in their cores. They're somewhere between the heaviest planets and the lightest stars, making them fascinating subjects of study. The formation process of these dwarfs involves the death of a star. When a star exhausts its fuel, it sheds its outer layers, leaving behind its core, the future white or brown dwarf. These dwarfs play a crucial role in the cosmic recycling process, contributing to the formation of new stars and planets. From the remnants of stars, we now move to the most abundant yet elusive, the red dwarf stars. Red and blue giant stars are fascinating objects, each with its own unique characteristics. Red giants, like the famous Betelgeuse in Orion, are stars at the sunset of their lives. They've exhausted their hydrogen fuel and have expanded, becoming over 100 times their original size. Their outer layers cool down, giving them a characteristic red hue. On the other hand, blue giants are among the hottest and most luminous stars in the universe. They burn their fuel at a ferocious rate, leading to a relatively shorter lifespan. Despite their fleeting existence, they play a critical role in the cosmos. The nuclear fusion in their cores creates heavier elements, including those necessary for life as we know it. Both red and blue giants have the potential to host life-bearing planets, opening up fascinating possibilities for astrobiology. From these colorful giants, we now move to the erratic and unpredictable, the variable stars. Variable and binary stars are some of the most interesting objects in the universe. With their ever-changing brightness and complex dance of gravity, variable stars, as their name suggests, are stars that change in brightness over time. Some may take days, others years, to complete a single cycle of brightening and dimming. This variability reveals fundamental information about a star's internal structure and the processes that fuel it. On another cosmic stage, we find binary stars. These are two stars which orbit around a common center of mass, locked in a gravitational tango. They often appear as a single point of light to the naked eye, but with a telescope, their dance becomes clear. Binary systems are incredibly important in astrophysics, not only for the understanding of stellar evolution, but also because they allow us to measure the universe in unique ways, such as verifying Einstein's theory of relativity. From these dancing stars, we now move to the densest and fastest, the neutron stars and pulsars. Neutron stars and pulsars are the remnants of massive stars that have undergone a supernova explosion. Their formation is a tale of cosmic drama, where stars many times the size of our Sun exhaust their nuclear fuel, collapsing under their own gravity, and then rebound in a catastrophic blast. What's left is a core so dense that a teaspoon of it would weigh as much as Mount Everest. Let's dive a bit deeper into these celestial objects. Neutron stars, as the name suggests, are made up almost entirely of neutrons. They are incredibly small, with diameters of about 20 kilometers, but don't let their size fool you. They are the densest objects in the universe, aside from black holes. To give you an idea of how dense a neutron star is, imagine squeezing 2 times the mass of the Sun into an area the size of a small city. Now, pulsars are a special type of neutron star. They spin incredibly fast and beam out a steady pulse of radiation, hence the name pulsar. The fastest known pulsar spins at an astonishing 700 times a second. That's faster than a kitchen blender. Both neutron stars and pulsars have intense magnetic fields, billions of times stronger than the Earth's. This magnetic field, combined with their rapid rotation, creates a beacon of electromagnetic radiation that sweeps across the cosmos like a lighthouse. These celestial objects are not just fascinating, but also extremely valuable to astronomers. They serve as cosmic laboratories, allowing scientists to test theories of matter and energy under extreme conditions that can't be replicated on Earth. In essence, neutron stars and pulsars are the cosmic equivalent of diamonds. Formed under immense pressure, they shine with a unique brilliance, illuminating the darkest corners of our understanding about the universe. From the densest to the fastest, we have journeyed through the fascinating world of stars. So how many types of stars do you now know? As we end our cosmic journey, we realize that the universe is much more diverse and fascinating than we ever imagined. We've traveled from the familiar glow of main sequence stars, the class our very own Sun belongs to the towering might of giant and supergiant stars. We've explored the enigmatic white and brown dwarf stars, the remnants of stars that have exhausted their nuclear fuels. Our exploration continued to the red and blue giant stars, each with their unique characteristics and life cycles. We then delved into the mystery of variable and binary stars, whose intriguing behaviors continue to captivate astronomers. And we concluded with the fascinating neutron stars and pulsars, the incredibly dense remnants of massive stars after a supernova explosion. We hope this journey has inspired you to continue exploring the universe, to appreciate its beauty, its complexity, and its infinite mysteries. Remember, every star has its own story to tell, and there are billions of stories waiting to be discovered in our vast universe.